welcome you all for the next session. Today we are going to see about an interesting topic, substituent and effect of substituent on reactivity. Myself Indumati, Assistant Professor, Department of Pharmaceutical Chemistry and Analysis, School of Pharmaceutical Science, Vistas. Yeah, what is mean by substituent? Before going into our topic, we have to know what is mean by substituent and what are all the compounds which can attach to the or which can substitute to the benzene ring. So now we are going to see the definition of substituent. It is nothing but an atom or group of atoms taking the place of another atom or group, and it also occupies a specific position in a molecule. These compounds are called substituent. Generally, in monosubstituted benzene, the hydrogen atom present in benzene, all the hydrogen atoms attached to the carbon in benzene are all are equivalent. So because of this nature, only one there is a possibility of formation of monosubstitution product. For example, if you see here, this is the structure of benzene, and this is the substituted. This is the substituted. This is a substituted product of benzene. Here G denotes the substituent. Okay, so in benzene, if substituent goes and attached to the carbon, it replaces the hydrogen atom in the benzene, and it leads the formation of the monosubstituted product. So what are all the examples for the monosubstituted product? Means phenol, aniline, benzoic acid, toluene. These are all the examples for the monosubstituted product. Okay, this is a structure of the benzene. Now we are going to see about the second substituent. Second substituent are nothing but the substitution which is going to occur in the monosubstituted product. Okay, so second substituent here, electrophile can occupy the remaining five positions in the benzene ring, that is remaining five carbon atoms in the benzene ring. Here the position 2 and 6 are equivalent, and it leads the formation of the ortho product, and the position 3 and 5 are equivalent, and it leads the formation of the meta product, and the position 4 is unique, and it leads the formation of the para product. If you see in this image, the first A, the substituent attached to the benzene is noted as A, and this is the monosubstituted product of benzene. So second and sixth position, in second and sixth position, if a substitution occurs, means it leads the formation of the ortho product, and it is denoted as ortho. And third and fifth position, if substitution occurs, means it may lead the formation of the meta product, and in fourth position, if the substitution occurs, means it may lead to the formation of the para product. Here in this diagram, you can clearly see the substituent and what are all the products we can get after the substitution in the monosubstituted product. Then next, for the substitution, there are two types of influences are occurring. So what are all the types of influences which produces the further substitutions are directive effect as well as activity effect. The substituent which is already present on the benzene ring exercises two types of influences for the further substitution. It is divided into two types, directive effect. It is also called as orientation effect and activity effect. So what is meant by directive effect? The first substituent may direct the next incoming substituent to ortho position, meta position or para position. These substitution depend on the nature of the substitution, and see, this is called directive or orientation effect. Okay, can you understand? Here in monosubstituted product, already one substituent is present. That substituent may direct the next incoming of the substituent. Okay, so this will naturally occur in the ortho position of the benzene ring or meta position of the benzene ring or para position of the benzene ring. So this incoming is depend on the nature of the substituent, and this whole process is called a directive effect. topic is the activity effect. If you see here, the substituent which is already present on the benzene ring may activate the benzene ring or deactivate the benzene ring. So based on the activation and the deactivation, the further substitution will occur. So this is called a activate effect. Okay. So these are all the activating substituent and these are all the deactivating substituent. Example, amino group, hydroxy group, methoxy group, methyl group. These compounds are comes under the activating substituent. And what are the examples of deactivating substituent? Means nitro group, cyanide group, then chloride group. These are all the examples of the deactivating substituent. Then what is meant by directive effect of substituent? We have seen that in monosubstitute benzene, there are 5 available hydrogens are present. Okay, so of these two ortho position is available and two meta position is available and one para position is available for the substituent. Okay, so the nature of the first substituent depends on the ring determines it. Okay, so what is my ortho para effect? So here ortho para effect and meta directing effects, two concepts are there. If the substitution occurs in the ortho and para position, means it may comes under the category of ortho para directing effect. If it occurs in substitution occurs in meta position, means it comes under the category of meta directing effect. So what is meant by ortho para directing effect? Certain substituents simultaneously direct the second substituent to the ortho position and the para position. So these compounds are called as ortho-para directors. For example, when phenol is nitrated, the only products obtained are orthonitrophenol and para-nitrophenol. And here, no meta-isomer is obtained. Okay, if you see the percentage here, the orthonitrophenol possibility of product is 53 percentage and 47 percentage of possibility of the para-nitrophenol product. So both are in the equivalent range only. So we can expect both these products at the simultaneously and the in the meanwhile. Okay. So here we are taking the phenol, to that we are going to add dilute nitric acid. It leads the formation of orthonitrophenol and para-nitrophenol. In this case, we are getting both the products, orthonitrophenol as well as para-nitrophenol. So here the OH group is considered as a ortho-para director, because this OH group only directs the substitution of nitro group in the ortho position as well as in the para position. Okay, the substituent OH is said to have nitro group and directed the nitro group to the ortho position as well as para position on the ring. Therefore, OH is designated as a ortho para director. Okay, the next concept is meta directing effect. Here, the substituent which direct the second incoming substituents primarily to the meta position are referred as meta directors. For example, nitration of nitrobenzene gives 93% of meta dinitrobenzene and only 6% of ortho dinitrobenzene and 1% of the para dinitrobenzene. Okay, see here, this is the structure of nitrobenzene. To this we are going to do nitration. It leads the formation of 6% of ortho dinitrobenzene, 1% of para dinitrobenzene and 93% of meta dinitrobenzene. Here the majority of the product obtained is meta product, so we are omitting these two, ortho as well as para, and we are taking it for as a product here. So the substituent nitro group which directs the second nitro group to the meta position, and this nitro group is designated as a meta director. Okay. So what are all the examples for the ortho, para and meta directors? So ortho, para directors examples are fluorine, chlorine, bromine, iodine, hydroxy group, methoxy group, amino group. These are all the examples which comes under the ortho, para directors. And examples for the meta directors are nitro group, sulfonyl group, cyanide group, acid group, aldehyde group. Okay, acetone group. These are all the examples for the meta directing groups. Okay, now we are going to see about activity effect. So activity effect is nothing but substituent which is already present on the benzene ring not only direct the position of an incoming group but also it influences the rate of reaction also. Okay. For example, if you take the structure of toluene, which is nitrated 25 times faster than the benzene itself. On the other hand, on nitration of chlorobenzene, which is 30 times lesser than the benzene. Okay, this means the presence of a methyl group on the benzene ring activates it to the aromatic electrophilic substitution. But the presence of chlorine group on the benzene ring, it deactivates for the further substitution. Okay, so this is activating. This is called activating effect, and the next one is the substituent which activates the aromatic ring for the further substitution is called an activating substituent or ring activator. Okay, the substituent which deactivates the aromatic ring to the further substitution is called a deactivating substituent or ring activator. So what are the examples for the activating substituent is amino group, hydroxy group, methoxy group, and a deactivating substituent is nitro group, cyanide group, and the chlorine group. These are all the examples for the deactivating substituent. So here the ortho para directors activates the ring towards the electrophilic substitution, whereas the meta directing groups deactivate the ring towards the electrophilic substitution. Although fluorine, chlorine, bromine, and iodine are ortho para directors, these substituents are also deactivate the aromatic ring for the further substitution. Okay, so I hope everyone understood the concept of a substituent and what are the various factors which influences the substitution. So I hope if you have any doubts, please comment me below. And thank you all for understanding this. Thank you.